Welcome to All About Matter Lesson 2, Atoms, Elements, Compounds, and Mixtures. Before we begin, you should know that this lesson has a lot of vocabulary, and if you're not familiar with these terms, you might want to pause the video and get a piece of paper or a Google document ready to take notes. All right, let's begin. Last time, we talked about matter, and we said that matter could be anything from a baseball to the air that we breathe, right? Well, what is all of that matter made of? In order to understand this difficult question, let's imagine for just a moment that we're holding on to a piece of aluminum foil. You were ripping it in half, and then you put those halves together and you rip it again, and you keep trying to rip it into smaller pieces. Could you do this tearing forever, constantly getting smaller pieces? Or would you eventually reach the point where you had the smallest possible piece of that foil? What do you think? Well, I can tell you about a Greek philosopher named Democritus who lived in the year 440 BC. I put some pictures of him on the left side of your screen so you could check him out. Democritus thought that you could cut matter into smaller pieces, but eventually you would get to the smallest possible piece. And he called this smallest possible piece atomos, meaning uncuttable. Does the word atomos look familiar to you? Just a hint, we're not talking about atmos like as in atmosphere. This is atomos. What does that look like to you? Well, this is where the word atom comes from. And the atom is the smallest part of an element. There's a computer-generated picture of what one might look like right here on your screen. Although atoms are extremely small, they're made of even smaller parts, the nucleus, proton, neutrons, and electrons. The nucleus is the tiny central core of the atom, which contains the protons and neutrons. It's right at the very center. The protons have a positive electric charge. They are represented by the slight blue greenish colored circles in the neutron in the center, excuse me, in the nucleus in the center of this image. Now, neutrons have no charge. They are neutral, and like the protons, they are in the center or nucleus of the atom. They're represented by the darker blue circles you see here. Electrons are different. They're very energetic particles that move in the space around the nucleus, and they carry a negative charge. The electrons are represented here by the sort of beigeish, orangish circles with a minus sign on them. Okay, now that we understand or have an idea about what an atom is, let's talk about elements. An element is a substance that's made of one type of atom. And I forgot to mention that. Atoms can have different characteristics. We'll talk about that idea later. So there's different types of atoms, and an element is just a substance that only has one of those types. It's kind of pure, is the way that I think of it. All elements can be identified by specific physical and chemical properties. So some examples are things like aluminum foil, copper coating that you see on a penny, oxygen and nitrogen gas. Also, the force that holds two elements together is called a chemical bond. All of the kinds of elements are found on the periodic table along with their symbols. And the periodic table looks like this. You've most likely seen one somewhere before. Okay, now we've talked about atoms and elements. Let's talk about compounds. A compound is a substance made of two or more elements chemically combined in a set ratio or proportion. That sounds difficult to understand, but it's actually not too bad. A molecule is also two or more atoms bonded together in a compound. So let's think for just a moment about compounds and molecules, right? So a compound, it says, is a substance made of two or more elements. I can think of one very familiar thing that is a compound something made of two or more elements. And that thing is water. Have you ever heard someone say H2O when they were referring to water? What they're referring to is two hydrogen atoms and one oxygen atom that chemically bond together to make, you guessed it, water. I have placed one molecule, or actually the three atoms that have bonded together to make a molecule of water right here on the bottom of your screen. Can you see the O in the middle of the blue circle and the two H's in the middle of those purple circles? Yeah, that represents water. That is one molecule of a compound known as water. And somebody saw it and kind of thought it looked like Mickey Mouse, so they put his picture on there too. That was pretty funny, I thought. I thought you might enjoy it. Okay, so elements and compounds. When elements are combined to make a compound, the new substance has properties that are different from those of the original elements, right? So if you think about what we were just talking about, water, you probably don't have a really helpful image of hydrogen. It's a colorless gas. However, you have a good idea about oxygen, right? It too is just a colorless gas. Are either of those things anything like what you think of when you think of water? No, that's because when we combine these different elements, these different pure substances, we put them together, they make something new once they've chemically bonded. They make something totally different than what they were before. On our screen, they give us another example of this. Table sugar, the sugar that your mom might put in her coffee, or you might put if you're baking something. It's made of three different elements: carbon, which is found in charcoal. And you probably think of charcoal as those black spheres that you use when you have a barbecue. Oxygen and hydrogen, as we already said, are colorless gases. Do either of those sound like they have anything in common with table sugar? Probably not, right? That's because when they come together to make a new compound, the substance they create is totally different than what the elements were on their own before they came together to make the new compound. Okay, it's time to talk about mixtures because most of matter occurs in mixtures. A mixture is made of two or more substances, and it can be elements, those pure substances that only have one type of atom, or compounds, the ones that have more than one type of atom that have been combined chemically. And in a mixture, the elements and compounds are in the same place, but they're not chemically combined. So here are some examples of mixtures on your screen. There's lemonade. It's a mixture of water, lemon juice, and sugar. A rock, if you look closely at this rock and many of the rocks that you'll see outside, you'll notice that there are very different things in that rock. You might see spots or lines of different color. That is a mixture because they haven't totally chemically bonded. You can still recognize the pieces of different substances in that rock. And it's very similar in salad dressing. If you look closely, you can see herbs and spices floating around in the oil and vinegar. And if you looked even closer, you could probably see little bubbles of oil that haven't quite chemically combined, which is why it's important to shake that salad dressing before you use it, right? So a mixture is different from a compound because the substances inside of the mixture, they're not chemically combined and they don't create anything that's very different from what the elements were or what the compounds were before they were mixed. So remember, mixtures are different from compounds in two ways. The substances in a mixture keep their individual properties. Like we said, in the salad dressing, we could still see the little pieces, the little bits of herbs and spices floating around. They still have their original properties. They didn't become anything totally different. And the second part is that the parts of a mixture are not necessarily present in set ratios. So this sounds difficult to understand. Let's think about it for a minute. Remember when we talked about water and we saw that molecule that kind of looked like Mickey Mouse? Well, water is always H2O. That means you need two hydrogen atoms and one oxygen atom to make water. But in a mixture, it's not quite like that. If you think about lemonade, lemonade doesn't always have the exact same recipe. One person may make it a certain way, maybe with 1 cup of lemon juice. Another person may make it with 1.5 cups of lemon juice. In a mixture, you don't always have the exact same amount of what you mixed to create it. So another example that they give you on our screen is soil. If you looked closely at soil, you would see that there are particles of sand, maybe some tiny bits of clay, and even dead and decaying plants. But if you grabbed a handful of soil and I grabbed a handful of soil and we did some kind of scientific experiment on it or scientific study to see what was in it, the chances are that what was in your sand and what was in, or excuse me, your soil and what was in my soil would be very different. And so it's a mixture because you don't have the exact same amount of each substance in a mixture. In a compound, you always have to have the same amount of your ingredients in order to make that compound. Here's another interesting way I thought you'd be able to see the difference between elements, compounds, and mixtures. An element is that pure substance. It's made of one type of atom, and an example would be copper. A compound has to have an exact recipe. It has to have exactly the right atoms in order to make something completely different than what was originally in the substances that created it. And then there's mixture. A mixture, it's not chemically combined at all. It's basically just mixed up. So the jelly beans that you see here, if you took a handful and I took a handful, it would be unlikely that we would have the same amount of red jelly beans because they're just mixed. The recipe isn't a perfect amount, and you can't be sure that you would have the same exact colors for each handful that you would grab. Okay, as we end out our lesson today, there was some really heavy thinking. So let's think through some things that we all know from our world and decide whether we're talking about a mixture or a compound. So Chex Mix, if you've never had this before, you can see the picture on your screen. It has a bunch of different treats. All of them are pretty much delicious. Do you think that's a mixture or a compound? Of course, the word mixed is in its name, and this is clearly a mixture, right? Again, those things are not chemically combined. No new substance was created. I could even probably pull out the pretzels and eat them if I wanted. Okay, table salt. Well, table salt is made of two elements that have been chemically combined. So table salt can't be a mixture. It's a compound. And how about water? Well, we just talked about water earlier in this video, right? Water is a compound because there's a specific recipe or proportion that has to be in water. You have to have two hydrogen atoms and one oxygen atom, and also they're chemically combined, right? So water is a compound. Well, how about muddy water? Well, the water itself is a compound, but the mud actually doesn't chemically combine with the atoms in the water. It's just sort of mixed up. In fact, if you leave it alone for a while, the chances are that the mud will eventually settle and separate from the water. And lastly, carbon dioxide. Carbon is an element, and dioxide means that you have two atoms of oxygen, and that is definitely chemically combined, so that makes it a compound. Okay, I hope today's lesson wasn't too challenging for you. If you have to watch it one more time or even more than that, that's fine. It's always here for you. All right, I hope you enjoyed it and have a great day.